Okay, for homework 1016, I want you to copy all this work and then write a key sentence for each one. For Math 1, you'll turn that work in. For Math 1 Honors, once you do all the work and write a key sentence for each one, you're going to make a flip grid explaining your key concept for each problem. So again, Math 1, do the work, write a sentence for each one. Math 1 Honors, do the work, write a complete sentence for each one, and then do a flip grid explaining each key point for each problem that you did. Alright, so here we go. Number 1. This one, what I'm looking at here is that these are being multiplied by 3, being times by 3, multiplied by 3. That makes this exponential, geometric, timesing by 3. First term, second term, third term, fourth term, which means the 0 term dividing by 3 to the left, or timesing by 1/3, which is the same as dividing by 3. Showing right here, 12 times 1/3, multiplying straight across, that gives me 12 over 3. That's where I get 4 out of that. So backtracking one step, that's going to be 4. So what I'd like you to do before you do this problem is write down both forms of explicit for this geometric sequence. I'm going to write f of x equals the 0 term times that common ratio number 3 raised to the x power. And again, don't worry about the variables here. X's are n's. Or f of x equals the first term 12 times that same common ratio to the x minus 1 power. And then again, you could see of these two, this one is no good because it's got the wrong power in there, not n minus 1. This one is no good because it has the wrong power again right there. If this was n minus 1, that would be good. If this was just plain old n, that would be good. The third one here is perfect. Matches everything. First term, common ratio, n minus 1. And then this bottom one has the wrong common ratio number in there, 4. So that is the choice right there. Alright, next problem. This one, again, tells you the first term, tells you that you're timesing that number by 7, and then the next number by 7, next number by 7, following the recursive pattern. So 4 times 7 gives me 28. 28 times 7 gives me 196. 196 times 7, since it's a big number, I'm writing it underneath, 1,372. And then that times 7 gives me 9604. So again, a key sentence you could write about this is just keep multiplying each previous number by 7. That's the recursive pattern. For this first one, you can maybe write, make sure you know if it's geometric or arithmetic, and then make sure you know what the 0 term is and the first term is, or know both equations. Know the 0 term times r to the x, or the first term equation times r to the x minus 1. So those are key sentences you could write for number 1 and for number 2. Alright, third problem. And again, writing those out. Those are the next 4 terms in the sequence. So this is the first term, f of 1, and then the next 4 are these right here. Okay, third term. This one, you're going to find the rate of change of y divided by the rate of change for x. This is going up by 4. This is going up by 2. The next set is going up by 4, going up by 2. The third one is going up by 6, but that one's okay because between 3 and 6 it's going up by 3. Will give me the same equivalent slope. So I could use, for slope, I could use 4 over 2, or I could use 6 over 3. All of those are good. 6 over 3 or 4 over 2. Each of those gives me a slope of 2. So when doing that problem, you have y equals mx plus b form before you write it in function notation. So there's my 2 for my slope, and then all I need to do is pick a point. I'm going to pick the point 1, 5, and that point that I pick, the 1 is going to go in the x spot, and the 5 is going to go right here in the y spot. So there's my 2 for my slope that I got first. Now to find b algebraically, 1 goes here, 5 goes here, solve for b. So that gives me, when I plug it in, 5 equals 2 times 1 plus that b. So that gives me 5 equals 2 plus b. And then I'm going to take away 2 on both sides, minus 2 minus 2. And that gives me b equals 3. And then when I put those numbers back together with f of x form equals 2x plus 3. So again, a key sentence on this one could be to, once you find slope and y-intercept, put those back into the original equation. Or you could say, pick any point to plug in for x and y. Those are key sentences you could write for this problem right here. Alright, next problem, number 4. And right here I'm doing the check. That's up to you. If you want to do that check, I'm checking the point 3, 9, plugging in 9 for y or f of x, plugging in 3 for x, and that should work if my equation's true. So 9 equals 6 plus 3, 9 equals 9. That check works. Okay, number 4. I want you to understand that the number in front of x is the rate. For this problem, monthly rent, $1,200 for every month. That's what this means. The 700 is the one-time deposit fee, or the y-intercept, or the zero term f of 0 is 700. You need to know all that. M is 1200. D is 1200. 1200 per month. So for this, it says deposit fee 700. That would be true. That's the y-intercept. 1200 would be false. Monthly rent, the rate, 1200 true. And then this last one, the sum of the deposit fee and the first month's rent. So after 1 month plus that deposit fee, you'd be paying 1200 for that month plus the deposit fee, which would be 1900. So the way this one's set up, that is true. And again, what you could say about this is know that the number in front of x is the rate. The plain number without an x is the y-intercept, or the one-time fee. Okay, for number 5. This one just wants you to find which one's exponential or the multiplying pattern. And I could see, first off, right away, timesing by 3, timesing by 3, timesing by 3. There it is right away. That one is exponential, geometric, timesing. The other ones are not, because this goes up by 4, adding by 4, linear. Adding by 4, same constant rate, linear. This one going up by 1 and then up by 2 and up by 3, that's a neither linear or exponential, because it's not the same pattern going up. That one's no good. And then the last one is a neither one, going up by 0, going up by 1, going up by 1. That is neither, not linear or exponential. So those are all bad. Only this top one is the exponential. So for this one, you could say, for exponential, find the sequence that is multiplying by the same number all the way through. Exponential, geometric. Okay, problem 6 wants you to see that from negative 61 to 43, I'm adding positive 18. And I got that by taking 61 minus 43 shows me it's going down by 18, so it's got to be adding 18. I know it's a little tricky with negative numbers, but negative 61 plus 18 whittles it down to negative 43. To find that zero term, subtract 18, and then know that negative 61 take away 18, you get even more negatives. You get negative 79 out of that. So the zero term is negative 79. This one's adding, so it's definitely arithmetic or linear. The explicit form, I'm going to write both. Make sure on test day you pick only one, because sometimes you make a mistake when you try to do both. So focus on one. So the explicit form with the zero term would be 18 times x, because it's an arithmetic linear one, plus or minus the zero term minus 79. Or f of x equals, and again, since this is linear, that same 18, but in parentheses x minus 1, plus or minus the first term minus 61. I would focus on the zero term one. That's the one we're going to use the most. The recursive form, f of x equals f of x minus 1 plus that 18, because I'm adding 18. A good sentence for this one would be to make sure if it's adding, you know it's arithmetic, or you could say when you find the equations, use the zero term to plug in if you needed to. Or you could say the recursive form always has this pattern, but then just adding the number at the end. So those are all key sentences you could write. All right, for number 9, this one for Math 1 is optional. Math 1 honors, this one is not optional. So here we go. Slope from these two coordinates, 0, 3, 20. The other coordinate 6, 500. Again, this is x, this is y. Second point's y. To find my slope, find the difference of the y numbers from each coordinate divided by the difference of the x numbers. Subtract the same order. Don't want to go this way and then subtract the other way. So 500 minus 320 divided by 6 minus 0. That gives me 180 divided by 6, which divides out to 30. Make sure you have the units. $30 for every 1 hour. Do not put 30 charges per hour. $30 for every 1 hour. And again, a key sentence would be to subtract the numbers in the same order. Or you could say, make sure to subtract the y coordinates up high and the x coordinates on the bottom. Or you could say, make sure to include the proper units at the end and get it down to your base unit rate. This is not a unit rate. Unit rate is $30 over 1. You need that over 1 for the unit rate. $30 for every 1 hour. Okay, problem number 10. For this one, again, this is geometric. To figure out what I'm dividing by, I took 729 divided by 243 is 3. 243 divided by 81 is 3, which means I'm dividing each one by 3. But remember, we show dividing by 3 as timesing by a third. So this times a third is dividing by 3. This times a third is dividing by 3. This times a third is dividing by 3. Going backwards, multiplying by 3, the opposite. So 729 times 3 gives me a large number. That is 2,187. Of course, that divided by 3 is 729, so that makes sense. The recursive pattern, always f of x equals f of x minus 1, but instead of adding a number, I write times 1/3. because I'm multiplying, this is geometric. And then the explicit form, again, focus on one. I'm just going to write both, the zero term and the first term one. But the explicit form is f of x equals the first zero term, 2,187 times the common ratio number 1/3 raised to the x power. If I want to use the first term, that would be f of x equals the first term, 729, times the common ratio number, 1/3, raised to the x minus 1 power. Focus on one of these. And again, a key sentence would be, if it's multiplying, know that the sequence is geometric. Or you could say, multiplying by 3, the opposite is timesing by 1/3. Or you could say, make sure the zero term has r to the x and the first term has r to the x minus 1. Those are all key sentences you could say. All right. Problem 13, again, optional for Math 1. Math 1 Honors, not optional. So for this one, from here to here going up by 4. Next term going up by 16, but that's okay because from here to here going up by 20. All of those numbers will give me equivalent fractions. So I could either use 4, because again these are the y numbers, 4 over 5, or I could use 16 over 20, or this 12 over 15. Any of those are equivalent. I'm going to use the smallest of the one, 4 over 5, with my units. So that 4 is 4 miles over 5 minutes. I need to make sure that I change this to miles per hour. So 4 miles over 5 minutes times 60 minutes for every 1 hour. And then when I time straight across, my minutes units will cancel and leave me miles over hour. But then I need to multiply 4 and 60 and divide that by 5. So again, the minutes units will cancel and leave me miles over hour. 4 times 60 gives me 240 miles over 5 hours. And then again, I need the base unit rate. That is not the unit rate. I need it over 1 hour. So if I divide that, that gives me, I believe, 48 miles for every 1 hour. And again, a key sentence would be use any ratio, or you could say make sure to show the work where the units cancel, or you could say divide it down to its base unit rate. Those are all key things you could say about this problem. Okay, 14. 14, again, recognition. This problem, decrease 190 every year. That's not a percent. It's not timesing, linear for this situation. Number 2, from 5 to 9 going up by 4. From 9 to 13 going up by 4. Constant rate going up, linear. Number 3, as soon as I see a percent, exponential. I'm timesing by 1.25 on this one. Exponential, growing by 1/4 of a percent. 1.25. This one, 100 each year, not a percent, linear. And then this last one, 30 divided by 3 is $10 per hour. And then when I divide 20 by 4, I get $5 per hour. Since those are not the same rate, this one is a neither problem. Not the same rate, neither. So for this, 1, 2, and 4 are linear. exponential for this set is number 3, and then neither for this set would be 5. A key sentence you could say is any percent problem exponential, or you could say any problem going up by the same amount each year or going up by the same amount each time linear. Or you could say any problem that does not have a common rate of change or a percent is neither. Those are things you could say. All right, next problem 15. For this one, this is geometric common ratio, not linear. So to find that R number, I'm going to divide this first term 327 by the 0 term 300. So 327 divided by 300 will give me the common ratio, which is 1.09. I'm going to write both explicits just for practice sake before I start looking. So if f of x equals the 0 term 300 times 1.09, and we could show times with parentheses, to the x power, or I could use the first term, which is 327 times that same common ratio number raised to the x minus 1 power. And I could see of my choices, this one has the 0 term but the wrong R. Wrong R on this one. This one is good, but the 0 term showing a minus 1, no good. This one is the only one that truly matches one of my equations here. So that one, the 0 term times R to the variable power. And again, for a key sentence for that one, you could say, make sure you find R by dividing the previous one by the one before it. Maybe you could say write both forms of explicit before you look at your choices. You could say the 0 term always R to the x, or the first term R to the x minus 1. Those are key sentences. All right, last set. For this one, you need to count number of white boxes. This is design 1, 2, 3. If we don't tell you what they are, we want you to assume that this is the first one, second one, third one, not the 0 one. 4 of those white boxes, 9 white boxes, 14 shows I'm going up by 5. First term, second term, third term. The 0 term subtracting 5. So 4 white boxes minus 5 gives me negative 1 number of white boxes. For this, again, before I match, I want you to write all 3 forms. Here's the explicit one, 5x plus or minus the 0 term, so minus 1. So you can see right there that matches. The second one, 5, that same 5 number, but times x minus 1 plus the first term 4, and you can see that matches that, but just a different order. And then the recursive form, f of x equals f of x minus 1 plus 5, that same d number 5. And I can see right away this first one has the wrong number in front of x. That one does not describe the number of white squares. This one is this one right here in a different order. This one is the recursive form right here, and then this last one is 5x minus 1, the 0 term with d. I'm going to have you use this 0 term 1, slope-intercept 1 is the most common, so 5x minus 1. I'm going to take 25 and plug it in for x. So the function at the 25th term equals 5, and right here I put the 25. This is just notation to show what I'm doing. This is actual math right here. 5 times 25 gives me 125. And then that take away 1 gives me 124. So the number of white squares is 124. Make sure you write that in that box. A key sentence for this set would be to make sure you write all 3 forms of the function. Or you could say, make sure to find the 25th term, you plug in x is 25. You could also say that anything not labeled is the first term, not the 0 term. You could write that too. Those are all key sentences. Alright, so for Math 1, copy the work, write a key sentence for each one, turn it in. For Math 1 Honors, write the work, and then do a Flipgrid explaining your key sentences that you wrote or that you're just going to tell me. For Math 1 Honors, it's going to be up to you if you want to document this work online. I'm mainly grading your Flipgrid, what you're saying about each problem after you've done the work. Good luck.